Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over some stoichiometry practice problems. So you can follow along and you can practice converting from one substance to another. So when we're talking about stoichiometry, we're talking about using a balanced equation in order to convert from one substance to a different substance in the equation. So you need a balanced equation for stoichiometry. And so therefore, you're going to be using what are called mole ratios from your balanced equation. The mole ratios come directly from the coefficients in your balanced equation. So when you're setting up your conversion factors or your mole ratios, you just use the numbers that they give you in the balanced equation. You don't need to simplify, just take it directly from the equation itself. So I'm going to go over I'm going to go but maybe 4 examples using the exact same equation and show you how you can be asked to calculate different things based on what they're giving you and what they want in the problem. Okay, so first I want to kind of go over or review what is called the conversion roadmap, the mole conversion roadmap, or what I call kind of the chemistry conversion highway, if you will. And so in the conversion highway, this is your main road. This is the main highway here. And then conversions off of this will be uh, side roads, if you will. So here, the main highway is this road right here. So when you're converting, normally you're going to convert mass in grams of some substance A to something, maybe it's moles of A, or to some other substance B. So in the problem, if they give you a substance A in grams, then and they asking, hey, what's the mass in grams of this other substance B in your equation, then you can use this to convert. So this is a nice kind of strategy to use or tool to use to help you remember how to get from point A to point B in your problem. So if you're given a mass A, then in order to get to a mass of a different substance in your equation, you're going to have to first use the molar mass of A to convert from grams of A to moles of A. And then you're going to have to use what is called the mole ratio in your balanced equation to convert moles of A to moles of B. And then use the molar mass of B to convert moles of B to mass of B in grams. So let me specify grams here. So this is in grams. Now, what if they don't give you grams, right? So if they give you kilograms, then you're off the highway, so to speak. So in order to get onto this main road, you need grams. So you'd have to convert kilograms to grams first, and then go through the process, go through the steps. What if you're given particles? Well, if you're given particles like molecules or atoms or ions or something like that, then you would have to use Avogadro's number to convert from the particles to moles, and now you're on the main highway. So again, this would be kind of like a side road. You want to get off of the side road onto the main highway in order to convert. So I'm going to go over a few examples using this equation right here. So we need to first always balance the equation, because without the balanced equation, you can't get your mole ratios. So let's go ahead and balance this equation. So we have N2H2 and NH3. So we'll save hydrogen for last. We'll balance the nitrogen first. So here we have one nitrogen. So we'll put a 2 here. So we can get 2 nitrogens. So now we have 2 nitrogens and 2 nitrogens. But now we have 2 times 3 is 6 hydrogens. And we only have 2 here. So we're going to have to put a 3 coefficient. So 3 times 2 is 6. So now our equation is balanced. So we have 2 nitrogen, and 3 times 2 is 6 hydrogen. 2 times 3 is 6 hydrogen. Okay, so, and we don't usually write ones here, so if it's blank, that's a 1, or if you want, you can write a 1, but we usually don't write ones for substances that just have 1. So here's our balanced equation. Now we can get our mole ratios. So the mole ratios come directly from the coefficients. So we want to write the ratios for the different substances. So we can have a ratio, mole ratio between nitrogen and hydrogen. We can have a mole ratio between nitrogen and ammonia, or we can have a mole ratio between hydrogen and ammonia. So let's go ahead and write those over here. So the mole ratio, and I'll write these as fractions, or what we say conversion factors. So the mole ratio between nitrogen and hydrogen is 1 to 3. So we can write this as 1 mole of nitrogen over 3 moles of hydrogen. So 3 moles H2. So that's 1. Or we could do nitrogen to ammonia. So it's 1 to 2. So we can write our mole ratio for nitrogen and ammonia. So 1 to 2. So for there, it's going to be 1 mole of nitrogen over 2 moles of ammonia, NH3. And then we have one more. So hydrogen to ammonia. So this is 3 to 2. So the mole ratio is 3 moles of hydrogen to 2 moles of ammonia. So let me, excuse me, let me bring this down a little bit. And so I have 3 moles of hydrogen, so 3 moles of H2 over 2 moles of NH3. So 2 moles NH3. Let me write this 2 better. Okay. So here's our mole ratios that we could use as conversion factors. And one thing I want to point out is that you can flip these to make new conversion factors. So you can either use 1 mole over nitrogen over 3 moles of hydrogen, or flip it and have 3 moles of hydrogen on top and 1 mole of nitrogen. So all of these can be flipped. So depending on the problem, you're going to use one of these, or you're going to flip it and use the conversion factor. So let's go ahead and start with the first problem. So here, they're giving us 60 moles of hydrogen, and they want some moles of nitrogen. We want to convert 60 moles of hydrogen into whatever certain moles of nitrogen using our balanced equation. So using our roadmap, where are we starting? We're starting with moles of hydrogen. That's going to be our A. A is where we start. B is where we end. So we want to convert from substance A to substance B. So this is A, and this is B. So we're starting with moles of A. So where are we? We're starting here. So we're starting here on our roadmap, and we want to get to moles of B, so we want to be here. So it's only one step, right? So we want to go from moles of A to moles of B, so we're going to have to use the mole ratio between A and B. What is A and B? Hydrogen and nitrogen. So we're going to use the mole ratio between hydrogen and nitrogen to do our conversion. So how do you set this up? So you set it up by, let me use blue. So I'm going to take 60 moles of hydrogen, put it over 1. Now you can do the line method where you're just drawing lines, right? And you draw a line like that, and then you have your next one is a conversion factor. So we only need to go from moles of A to moles of B, so it's one step. So we're going to use our mole ratio. So the mole ratio between hydrogen and nitrogen, A and B. So hydrogen and nitrogen, the mole ratio is 1 to 3. I have moles of hydrogen on the top. Whatever's on the top needs to go on the bottom here for the units to cancel out the units. So moles of hydrogen is on top here. So I have to have moles of hydrogen down here. So I have 3 moles of hydrogen. So 3 moles of H2 is on the bottom, and then the 1 mole of nitrogen goes on top. 1 mole of nitrogen goes on top. So now moles of hydrogen cancel out. Now I have moles of nitrogen, which is what they're asking for. So I am done. I've gone from point A to point B. So I am finished. So now all I need to do is do the calculation on my calculator. So 60 divided by 3 gives me 20 moles. We'll abbreviate it. You only need, so 20 moles of N2. So that's how you go about using stoichiometry. So remember, stoichiometry is where you're using a balanced equation to convert from one substance to another. And that reason is because that balanced equation gives you the mole ratio. Without the mole ratio, you can't convert from one substance to another. So this is why the balanced equation here is important. Okay, so let's try another problem. So in my other problem, we'll do 54 grams. So let's go ahead and erase this. We'll do number 2. So they're giving us 54 grams of what? 54 grams of N2. And they want us to convert that to grams of NH3. So in this problem, it's a little bit longer, right? So we're starting with grams of one substance, and they're giving us grams of a different substance. So where are we going to start? We start with what we know, and we're going to end with what we don't know. So this is going to be our A, and this is our B. So we want grams of A. We're given grams of A. We want grams of B. So we're starting with mass of A in grams, but we want to get all the way here to mass in grams for B. And so that means we need to go through 1, 2, 3 steps in our roadmap. So here, the first step is to use the molar mass of A to convert grams of A to moles of A. And then we're going to use the mole ratio to convert between moles of A to moles of B. And then our final step will be to use the molar mass of B to convert between moles of B and grams of B. So let's go ahead and do these steps. So we're starting here, mass of A. So they're giving us mass of A. So we're starting with 54 grams of N2 over 1. So I'm not doing the line method. You can do the multiply by conversion factors where you're not using the lines. It's up to you which one you want to use. So here, now my first conversion is to use the molar mass of A. Well, what's the molar mass of A? So the molar mass of A, if you look it up, nitrogen is 14.01. So this is going to be like 28.02 about. So that means that 28.02 grams is equal to 1 mole of nitrogen. So I have grams of nitrogen on top, so I want grams on the bottom. So the 28.02 grams of N2 is on the bottom, and then 1 mole of N2 is on top. Let me just verify the molar mass really quick. All right, that is correct. All right, so grams of N2 cancel out. Now I have moles of N2. So now I'm here. Now I want to get to here, so I'm going to use the mole ratio. So I'm going to use the mole ratio between N2 and NH3. So here's N2 and NH3, so it's 1:2 ratio. So I have moles of N2 on the top, so I want moles of N2 on the bottom. So 1 mole of N2, so 1 mole of N2 on the bottom. And that means that 2 moles of NH3 on top. So 2 moles NH3 on top. So moles of N2 cancel out. Now I have moles of NH3, which is my B, right? B. So now I'm at moles of B. I have one more step. Last step, molar mass of B converts to grams of B. So I'm going to need my next conversion factor, which is the molar mass of NH3. So N is 14.01, hydrogen is 1.008. So if you calculate that, that's going to be about 17. So about 17, 14 plus 3, 17. So it's going to be a little more than 17, but we'll round just for the sake of this example. So 17, let's say 17 grams. So 17 grams per mole. We want moles on the bottom because we have moles of NH3 on top. So that's why it's really important to write down the unit and the substance. So I have moles of NH3 on top here. I want to cancel that out. So I want moles of NH3 on the bottom. So I have 1 mole of NH3 on the bottom is equal to, what did I say, 17 grams of NH3 on the top. So now moles of NH3 cancels out, and I'm left with grams of NH3, which is mass. That's my mass of B. So I'm right here. That's what they want in the problem. They want grams of NH3. I've got grams of NH3. So now all I need to do is calculate the answer. So you calculate the answer by, let me get my calculator really quick. Okay, so I take 54 and I multiply across the top. So 54 times 2 times 17 divided by, and I divide by everything on the bottom. So divided by 28.02 equals, and I get about 65.5 grams. So that's going to be equal to 65.5 grams of ammonia. Okay, you'll notice that I didn't do anything with the ones. You don't need to multiply or divide by ones. They don't do anything, so you could skip over that. But I do always, well, not always, but I pretty much always multiply across the top and divide by whatever's on the bottom. So if there was a 2 here, then I would divide by 28.02 and then divide again by 2 in my calculator. Sometimes I'll do in order here. So I'll take 54 and then divide it by 28.02 and then multiply by 2 and then multiply by 17. It comes out the same. Okay, so that's number 2. What about example number 3? So let's go ahead and do example number 3. So example number 3, we're using the exact same equation. So in example number 3, what do they want? They give us 6.05 times 10 to the 57. 6.05 times 10 to the 57 molecules, I believe, molecules of NH3. And what do they want? They want us to convert that to molecules of N2. So what's my A and B? So where am I beginning? I'm beginning with what I know, which is I have 6.05 times 10 to the 57 molecules of NH3. So molecules of NH3 is my A. So NH3 is my A, and N2 is my B. So I'm starting with NH3, and I'm going to end with N2. So they're giving me molecules, and they want me to end with molecules. So where am I beginning on my map? Well, molecules is a particle. So I'm beginning here with particles of A, and I want to get to here with particles of B. So I'm going to have to go this route here. So my first step is to use Avogadro's number to convert particles to moles. So remember, Avogadro's number is 6.022 times 10 to the 23rd. That's 1 mole. So 1 mole is equal to that number of particles. So, like normal, we start with what we're given. So we're given 6.05 times 10 to the 57 over 1. And remember, this is molecules. We write out our units. Molecules of what? We have to write our substance, NH3. So we're going to, first step, we got particles. We want to go from particles to moles of A. So we're going to use Avogadro's numbers. Remember, if we want to convert from one substance to another, we have to go through the mole ratio. All right, so here we go. So I know that 6.022 times 10 to the 23rd molecules of NH3 is equal to 1 mole of NH3. So since I have molecules of NH3 on the top, I want molecules on the bottom. So I'm going to put 6.022 times 10 to the 23rd molecules. I'll shorten that to molecules. And then NH3 to 1 mole of NH3. So molecules of NH3 cancel out. Now I have moles. So now I'm here. I have moles of A. I want to go from moles of A to moles of B. So I'm going to use the mole ratio. So this time it's between NH3, ammonia, and nitrogen. So ammonia and nitrogen. So it's going to be 2 to 1. So I set up my mole ratio. I have moles of NH3 on top. So I want moles of NH3 on the bottom. So that's going to be 2 moles. I'm using the coefficients from the equation. So 2 moles of NH3. And I want N2 on top. So I want 1 mole of N2 on top. So 1 mole of N2 on top. So moles of NH3 cancel out. Now I have moles of N2, but they don't want moles of N2. They want molecules of N2. So now I'm here in my roadmap. Now I need to get to here. So I'm going to use Avogadro's number again. This time I'm converting moles into molecules. So I'm going to use the same conversion, but I'm going to flip it. So here, let me shorten this a little. So since I have 1 mole of NH3, N2 on the top, I want moles of NH3 on the bottom. So 1 mole of N2, 1 mole of N2 on the bottom. And so Avogadro's number, 6.022 times 10 to the 23rd on top. So 6.022 times 10 to the 23rd. And this is again going to be molecules. I'll shorten to molecules of N2. So now moles of N2 cancel out. And you'll notice that I have molecules of N2 on top here. So I'm finished because the problem is asking for molecules of N2. So now all I need to do is calculate. So I calculate this on my calculator. And so give me a moment while I calculate this. Okay, so you calculate this out. So you have 6.05 times 10 to the 57 multiplied by, well, these are ones, multiplied by 6.022 times 10 to the 23rd, and then you divide by what's on the bottom. Divide by 6.022 times 10 to the 23rd, divide by 2, and then you get your answer. Or you could see that I have 6.022 times 10 to the 23rd on the bottom here. I have it on the top there, so those numbers are gonna cancel out. So it ends up being this number divided by 2, which when you calculate that out, that becomes, what did I calculate it out? So 3.027 times 10 to the 57 molecules of N2. So that would be the answer to this problem here. Okay, let's go on to problem number 4, the last problem. Okay, so problem number 4. They're giving us 4.12. So 4.12 times 10 to the 12. And what is that? They're giving us molecules of H2. Molecules of H2, and they want us to convert that to grams of NH3, grams of NH3. So we're starting with molecules. So we're starting here, molecules of A, particles of A, and we want to get to grams of B. So we're going to follow our roadmap. So first thing we need to do is convert to moles. So we're going to take 4.12 times 10 to the 12 molecules of H2 over 1, and we're going to convert that to moles. We're going to use Avogadro's number. So using Avogadro's number to get to moles, so that's going to be 6.022 times 10 to the 23rd molecules of H2, and on the top 1 mole of H2. So molecules of H2 cancel out. Next, we're going to use mole ratio to get to moles of A to moles of B. So we want to go from hydrogen to NH3. So hydrogen is 3, NH3 is 2. So moles of H2 is on the bottom. So I have 3 moles of H2, and then 2 moles of NH3 on the top. So moles of H2 cancel out. So now I am here. So now I'm going to convert moles of B to mass of B grams using the molar mass. And again, the molar mass is about 17. So 1 mole of NH3 on the top, on the bottom, and then 17 grams of NH3 on top. Moles of NH3 cancel out. I have grams of NH3. They want grams of NH3. I am done. No more conversion factors. So all I need to do is multiply and divide. So let's see what I get. Okay, and so the answer is 7.75 times 10 to the negative 11 grams of NH3. So yes, that is a small number. That is the correct answer. I hope this is helpful. If you learned a lot from this video, Please make sure you like, share, subscribe to my channel, hit that notification bell, and put a comment down below. Thanks.